This is an animation I made of a UFO abducting a house. I originally made it for like TikTok and Instagram, and I had a request for tutorials on this, so I made a tutorial showing how I made and animated the UFO and made all of these cool light patterns underneath it. You can see right here. So this video is me converting all of that to a horizontal aspect ratio to post on YouTube. So with all that being said, this is the tutorial. Select everything, delete it, add a mesh circle. I'm keeping mine at 32 vertices. In edit mode, press E and then S to extrude and scale down. Then press E and then Z to extrude it and move it up on the Z axis. Alt click this outer edge loop, extrude it, scale it out. Then press G and Z to move it up the Z axis and make this little cone. Select this top loop, press F to fill. Press Ctrl 2 to add a subdivision surface modifier with 2 subdivisions. Select this top circle, press I to inset. Press Ctrl R to add a loop cut on this cylinder and bring it up to the top. Add another loop cut, bring it down to the bottom. Do the same thing for the outside of this cone. Loop select the faces of this outer ring and inset them a little bit. Confirm that and then press I twice to inset on individual faces. Extrude those up, click to confirm. Then extrude them up one more time a little bit so they're flat at the top. Add another circle, this time with 64 vertices. Move it up the Z axis. Extrude and scale out. Extrude, move it up. Extrude out and up again. Then extrude in, up, and then in. Then press M to merge those vertices at the center. Press Ctrl 2 for subdivision surface and we have a UFO. Obviously you don't have to copy what I did verbatim, but this gives you a good idea of how to make one of these guys yourself. Now we want to add materials. Select this bottom hatch that we made, give it a material, I just named it UFO, then give it another material and name that lights. Click on one of these tiny faces that we extruded in earlier, go to select similar, and then area, and then bring down the threshold until all of the little faces for the lights are selected. Then with your lights material selected, click assign. Then if you scroll down, give it an emission color and then give it some emission strength. The material only applied to this kind of weird looking square. You want to alt click these extra tiny little extruded faces and select all of them by using that select similar area, and then assign the light material again. And now the entire bottom of those little holes are filled with light. For the actual UFO, this grid pattern was made with procedural material. So to do that, select the UFO material, open a shader editor window, add a brick texture, plug it into the color for now. Make sure your Node Wrangler add-on is enabled. You can do this by going to Edit, Preferences, Add-on, search for, and enable Node Wrangler. Now click on your brick texture, press Ctrl T, plug this object node into Vector. Now add a gradient texture, place it in between the mapping and brick texture nodes, and set it to radial. Now when I go to the brick texture and set the scale to 8, it lines up with the lights perfectly. I'm assuming that's because the circle has 32 vertices and therefore 32 lights around the ring. And 32 divided by 4 is 8. I don't know how this works, but I tried it with like 24 lights around a ring, 40 lights around a ring, and if you just take the lights around the ring, divide them by 4, and set that number as the scale of the brick texture, it just works, it lines up. I don't know how that works, but it seems consistent. So you can adjust the mortar size to adjust the thickness of these lines. To make the concentric rings, duplicate the brick texture and the gradient texture. Set the gradient texture to spherical, and let's also duplicate the mapping node, plug that into the vector, and bring the scale of this mapping node down until it covers the entire mesh. Now add a mix node, set it to color, plug in both of those brick textures, set the mix node to multiply, bring up the factor all the way, and now we have a grid. Now unplug this from the base color and plug it into the roughness instead. Also add a bump node, plug that into the normal, and plug the mix node into the height. I also wanted surface imperfection, so I added a noise texture, plugged the mapping node into the vector, duplicated my mix texture and placed that in between the original mix texture and the roughness, plugged the noise texture into the second input, and added a color ramp in between. Then I turned up the detail and the roughness of the noise texture. Now I want to select the entire craft and give it the same UFO texture, but make a copy so I can edit this one without affecting the original. For the mapping node at the bottom, I brought down the scale again until it fills up the craft. I brought down the mortar size of the rings even more to about 0.005 to make them thinner. For each UFO texture, I made them a dark gray and I brought up the metallic property. Now to make a door that opens and closes, add another circle. I'm going to hide everything else so I can see what I'm doing. In edit mode, delete half of the vertices, select the 2 vertices at the end, press F to fill. Select everything, press F to fill. Really quick, let's just add an empty. Give your half circle a solidify modifier, then give it a mirror modifier, select your empty as the mirror object. Now add a cylinder. In object data properties and viewport display it as a wire. Give the half circle a Boolean modifier. Select the cylinder as the object and set it to intersect. When you move the circle down the x-axis, that's how you open and close the door. Now if I brought the circles too close together, they would just disappear and glitch out. Bringing the mirror modifier down to the bottom of the modifier stack, fix that. Now I can unhide everything and move the doors up so they're not clipping through the rim lights. And that's a door. I also gave it a new material, called it metal, made it dark gray and metallic with the noise texture plugged into the roughness. For these rings of light in the tube, I added a curved circle, scaled it down a little bit. In object properties and geometry, I gave it some depth. Then I added an array modifier and arrayed it up the z-axis, moved that up above the hatch door, and gave it the same light texture we did earlier. Then I animated the relative offset of the z-axis to have them contract down. I also added a spotlight and moved it up the hatch. We also want to see the spotlight, so I add a cube, scale it up, go to the shader editor, add a new material, name it volume, delete the principled BSDF thing, add a principled volume, plug that into volume and set the density to like 0.01. Right now in this scene that I'm doing for the tutorial, I thought that a power of 10,000 watts looked good, but then I looked at the animation I'd made before and it was at 300,000. So I guess whatever is going to work for your scene. Now select every object, shift click on the bottom hatch so it turns bright orange, press Ctrl P, select parent to object. Now that everything is parented to the bottom hatch, you can use that to move and rotate the entire ship. Now we're going to animate all this. Open up a timeline window. I'm going to bring my playhead to frame 60, select the door and adjust the X location to close it, add a keyframe. Bring the playhead over 4 frames, open the door, add another keyframe. Right click both keyframes, set the interpolation to linear. To animate these rings to contract down, I brought my playhead further down the timeline, set a keyframe for the relative offset in the array modifier, brought the playhead to the exact frame the doors start to open, brought the offset up, and added a keyframe there, so they start to contract down the moment the door is open. Now I want them to start quickly and ease into place, so I opened the graph editor window, took the handle for the first frame and moved it all the way in, and the handle for the last keyframe I moved all the way to the start. For the rim lights, I animated the emission texture so its final strength is at 10 at frame 60, and then at frame 0 its strength is at 0. So its brightness kind of builds up until the door opens. Obviously you don't need to use these exact keyframes, but the point I'm trying to illustrate here is that all these animations are centered around the door snapping open, so the mechanics have a kind of build and release effect. Also, for the spotlight I added a keyframe for whatever brightness I had it set to, then the keyframe right before it I set it to 0 so it instantly turns on like a light switch. Now we're going to make these lights, these fancy lights with geometry nodes. Press Shift A to add a plane, open a geometry node window, press Shift A again, search for and add a curved circle. I made its resolution 12, add an instance on points node and drop it on that line going from the curve to the group output, and now the curve will automatically be plugged into points. Now add another curved circle and plug that into the instance. The instance on points node takes the circle plugged into the instance input and makes copies of it, and the mesh plugged into the points node tells those copies where to go. And that mesh is a circle with 12 vertices, and therefore we have 12 circles arranged in a circle. Now add a curve to mesh node, add a curve line, and plug that into the profile. Bring all the coordinates for the endpoint to 0, and here I brought the x coordinate to 0.04. And now these circles will have a two-dimensional width of 0.04, and that's because the curve to mesh node is taking the shape of this line and wrapping it around the curve. I also added a trim curve node for the instant circle, and this allows me to kind of animate the circles being drawn in. Now in order to keyframe different properties, I need to plug them into the group input so they'll appear in the modifier tab. Here I'm just going to plug in the radius for both circles and the trim curve control. Both of these are labeled as radius, and that gets confusing really fast, so I can press N to open the side menu, select the group tab, and relabel the first radius as width, because adjusting that seems to change the width of this kind of donut shape. And this geometry node setup is done, so I'm going to name it pattern 1. I'm going to add a new geometry node modifier, name that pattern 2. Add a curved spiral node, set the height and the start radius to 0 and the rotations to 0.4. Add a curve to mesh node, add another curved line and plug that into the profile. This time I'll change the x parameter of the start point to negative 0.01 and positive 0.01 for the end point. This way the stroke has a total width of 0.02 and centered on the curve instead of extruding off to the side. We want to make another circular array for the spiral. So add an instance on points node with the spiral as the instance and add a circle to act as the points. If I set the spiral rotations to 0, you'll notice they're all pointed in one direction, but I want them all to point outward from the circle. Add an align Euler to vector node, and this makes more sense if you think of it as align axis to vector node. The x-axis is already selected, so adding a normal node and plugging that into the vector will take the x-axis of every spiral and align it to the normals of the circle instead of the x-axis. I know that I want to animate the rotation, start radius, and end radius of the spiral, so I'll plug those into the group input. Now duplicate the spiral and plug in all the parameters from the group input again. This makes it so if I make any changes in the modifiers tab, both spirals will stay identical. Duplicate the instance on points node, plug the spiral into points this time, and then add a curved circle, plug that into the instances, and add a fill curve node to fill in the circles. Now we want the circles to grow as they go up the length of the curve. So we can take the spline parameter node and plug the factor into the scale of the instances. This factor gives a value of 0 at the start of the curve and 1 at the end, gradually going up from 0 to 1 down the length of the curve. I can control this by adding a float curve in between. Now the original factor is going from 0 to 1 on the x-axis, and I can adjust the value by changing the points of the curve on the y-axis. In this case, the x-axis is like the length of the curve and the y-axis will be the scale of the circles. So if I bring this endpoint all the way down, this creates a bump in the middle where now the scale goes from 0 to something over 0.5 and back to 0. And so the scale of the circles goes from 0 to 0.5 to 0 as they go up the curve. This is how I animated the circles to pulse in and out, but for now I'm going to keep that value at 1. Now we'll want to animate the circles to grow in and out, so add a math node at the beginning. As you bring that value to -1, you subtract the scale of all of the circles and they gradually disappear. Plug it into the group input and I labeled it as circles in. I also want to animate the pulse effect on top of that. So duplicate the math and float curve nodes, plug in the spline factor, plug both of them into a math node to add the values together, and bring the endpoint of this float curve back down to 0. Don't forget to plug that math value into the group input and label it as pulse. Now to array all of these in a circle like before, add another instance on points node, plug the circle from before into points and the Euler to vector into the rotation, add a join geometry node at the end, plug in the original spirals. Also add a trim curve node for the first spiral and plug that into the input to animate it. By the way, the reason I have this spiral separate from the original spiral is because I want the visible spiral to have a higher resolution without adding more circles, because turning up the resolution makes more points and that makes more circles and I don't want that. Now at a realize instance node at the end, we'll actually need to set their material in the geometry node editor. So add a set material node at the end and then add another join geometry node after that. This join geometry node is for our original pattern, which we can plug back in from the geometry of the group input, and add another set material on that line just for the sake of each design having its own separate material. I usually plug these into the group input as well so I can easily access them in the modifier tab. Now go to the material tab, add a new material, and then select it for both material nodes. Now in a material editor window, add a gradient texture, plug it into the emission color, set it to quadratic sphere, press Ctrl T to map it, plug object into vector, bring down the scale until the gradient covers the mesh, and add a color ramp after the gradient. I set the colors of this gradient to go from deep purple to light blue, then I'll add like more color points in the middle, so I can keep its saturation and have more control over how the colors blend into each other. I also changed the interpolation from ease to cardinal. I don't know the exact difference, like what it's doing exactly, but it seems to look better. Then I duplicated that gradient and set it aside to start again, this time going from pinkish red to light orange. Once you're happy with that, click the icon to create a duplicate of the material, delete the second color ramp, and plug the first one back in. Then select the duplicate gradient material for the second material slot, and now both of these have their own gradient. Next we want to shrink wrap the lights onto the UFO, so give it a shrink wrap modifier, set the main section of this UFO as the target. You can use the offset to raise up the mesh a little bit off of the UFO so they don't like intersect with it. I had also used the solidify modifier to keep the top faces above the surface without having to use the offset so much that it's obviously floating. I also ran into this issue where these designs solidify or extrude in opposite directions. That means I need to flip the faces for one of them. So I went to the geometry node window for the first light design and added a flip faces node at the end. You'll also want to parent the lights to the UFO. We've already parented all the separate parts of the UFO to the hatch at the center, so you'll want to click on the lights, then the hatch, then press Ctrl P to parent, so I can move the UFO as much as I want and the lights are now stuck onto it. Add a transform node at the end of each geometry node setup so you can plug the rotation into the group input and animate their Z rotation. Now open a graph editor window to start animating. The general structure of this animation was that both designs animate in, trade places, and animate out. To animate in the spirals, first the trim curve is keyframed from 0 to 1, the pulse is animated from -1 to +1, and then the circles and controls animated from -1 to 0. This circular array starts with a width of 0, while I use the trim curve to animate it in, and then it expands out by increasing the width, radius, and Z rotation, with all three of these keyframes starting and ending at the same frame, so it looks like one motion. Later on I decreased the radius so it's closer to the center and animated the spiral to make the start radius larger than the end radius, with the end radius increased so it stays on the outer edge of this boundary, and then both of them are animated out in the same way they're animated in, but in reverse. I'm outlining a very step-by-step linear process just to really show exactly what I did and give you something to work with. The main takeaway here is that the animation is built by keyframing very simple movements, adjusting their motion using the handles in the graph editor, and layering them together where they start to look more and more complex. And obviously there are a lot more possibilities that I never touched on. I would recommend playing around with and seeing what works yourself. So I hope this made sense for the most part. I lose a lot of people when I start talking about geometry nodes, and it can be honestly really unintuitive and intimidating until you start to get the hang of how it works and how to make things with it. Moving forward with making your own designs, this node setup by itself is the most important part. You can screenshot it and you have it as a reference. That's all you need for creating radial symmetry or circular arrays. This video by CG Cookie is great for having a better understanding of the Euler to vector node. That's where I learned it's pronounced Euler too. It looks like it should be pronounced Euler. These are also two-dimensional versions of these 3D mandalas I made previously, and I have a TikTok where I talk about how I made those, where you can watch me for 5 or 6 minutes as I pronounce and spell mandala as Mandela, as in Nelson Mandela, and it's up there forever now.